Hi, I'm Margaret. In this video I'm going to show you how to implement the interface Iterable. I already opened the class word list that we started in a prior CE, and I also added after my test code a section for testing the iterator using the foreach loop. You can see there is a syntax error because we can only use the foreach loop in combination with either arrays or instances of Java lang iterable. Now my word list is not an iterable yet, but we're going to change this. So I'm going to go right here to my class word list and I say it implements iterable. And now we have to decide what type argument should we use. I can look this up in my class node. My node tells me that my item is of type string. We want to iterate over the items in our list, so this needs to be an iterable string. At this point, we declare that we implement iterable, but we haven't created the abstract methods yet. Let's find out what those are. So I'm going to the documentation. I can see my interface iterable has 3 methods. 2 of them have a default implementation, but one of them needs my attention. That is the iterator method. I'm going to click on it. It tells us it returns an iterator over the elements of type T. It says, great, we can do that. Let's go back here and implement it. If I roll over this red squiggly line, I can click on add unimplemented methods and Eclipse is going to give me a method stub. It typically places that at the very bottom, and sure enough, there it is. But you don't want to leave it here, so make sure you move that above the test code. So here I have my test client, and the test client should not be mixed in the middle of your class declaration. So make sure you move up whatever methods are auto-generated and make sure you have only the test code at the very end. So here we have this iterator. Right now it returns null. It should return an iterator of type string. And in order to do that, one way we can create something that is an iterator of type string is by creating a class that implements this iterator string interface like this. I make a private class. I'm going to call this my word list iterator, and it implements exactly what the iterator method expects, which is an iterator of string. And at this point, we again have a similar situation as before. We have this red squiggly line. Eclipse offers us to add the unimplemented methods, and those are has, next, and next. Now you might wonder, how did we come up with those methods? We can look this up in the documentation. So here I can see my iterator method returns an iterator. I right click and open that in a new tab. That opens the documentation for my iterator interface, and my iterator interface has 4 methods. 2 of them have a default implementation, but 2 of them, next and has next, they need our attention. So every time we implement an interface, we should look carefully, what are these methods supposed to do? What is the contract? So let's check it out. Here my has next method should return true if the iteration has more elements and false otherwise. Now the next method should return the next element in the iteration if there is one. However, if there is no next element, then we should throw a no such element exception. That is important. We will do that. So at this point we have the class wordlist iterator and we have the method iterator. We still have 3 methods that need implementation. Let's focus on the class wordlist iterator first. So here we need to figure out a way to navigate through all the elements in our word list and to decide at the current position whether there is another item, and if so, how to return it. Let's scroll up here to the fields. When I look at the fields, I can see my word list is a singly linked list. I can see this because of my class node here. And every time we have a singly linked list, we start at the head and we navigate from one node to the next one until my node next is null. Once my node is null, we are beyond the last element. Very important when you implement the iterator, you must not change the fields from your word list class. That's important because I need to be able to iterate over it as often as I like, and it must not affect the word list class itself. That means I must not change head, I must not change end, I must not change tail. Now, how can I iterate over the elements without changing my fields? We have done similar tricks before with other methods. For example, the toString method, we were using a separate variable that points to the current element and allows us to access one node after the other. And of course, we started with the head. So let's go down to our method here. A great place to put this variable is inside my word list class as a field, because this way it gets initialized once and it maintains the state between method calls. So here I'm going to have a private node, I call it current, and I initialize it with head. Now the next method returns true if current is not null. So as long as current points to any node that has a string, we should say true. Once current is null, there is no string, it should return false. So let's write this as an if statement. I can say if current is not null, then return true, and otherwise return false. Now, this is the right logic, but it's not really good code. We can improve this, because what we are really saying is if the condition is true, return true. If the condition is false, return false. So a more simpler and better way to do that is to just say return the condition. Let's refactor that. It's going to look like this. That is the exact same logic, but better code. So at this point we have the implementation of our hasNext method. The next thing is we need to implement next. If I remind myself here, I can see we need to throw the no such element exception if there is no other element. That means once my current field is null. So I can say if as next, if that is not the case, then throw a new no such element exception. Of course, we're going to include a message. I can say can't access the next element because there is none. And you might come up with a better message, but importantly, make sure you have a message that is descriptive. And here I want to make sure I import a no such element exception from Java util. Single empty line. So here we start with the import validation, single empty line. At this point, I can be certain that we have an element that needs to be returned. So there might be a temptation to just say return current item. But if I return my element, I should also move my current to the next element. One way to do that is like this. I can say I have a string that is called temp, and this is my current.item, and then I am going to return this temporarily saved string later, but in between I'm going to update my current. So I say current is current next. So I move to the next node, which might point to another word or which might be null. So at this point, I am nearly finished because here I completed my word list iterator class. It still reminds me with the yellow squiggly line that it hasn't been used. That's where the method iterator comes in. We shouldn't return null. We should return an instance of my word list iterator because that is an iterator string, exactly what it asks for. So here we say we want to return a new word list iterator like this. And at this point, I'm going to save it, and you can see now my syntax error disappeared. When I scroll down here, I can run my for each loop. Let's do that. When I run it, it says the list with the for each loop gives me cat, cow, dog, eel, exactly the same elements that I accessed before with my toString method. So My iterator works nicely, which is awesome. Now I'm also going to show you how we could access the iterator directly. It's a best practice to access it through foreach, so please do that. But out of interest or for testing, it's also nice to know how you can access the iterator explicitly. So let's do that. Here I'm going to print the list using Iterator explicitly. And the way I do this is like this. I have an iterator and I obtain it from my list. And now I'm going to check whether there is a next item. If the iterator has next, well, if that is the case, then I'm going to print the element. I'm going to access it and I'm going to add a space after it because, of course, we want to make sure that the elements are separated. We need a semicolon here, and at this point I was using the iterator explicitly rather than a for each loop. Notice the for each loop is more concise, simple, clear. It's the preferred way to iterate over a list in Java. But knowing how to use the iterator explicitly can be very helpful when you need to debug it. So let's just run it and make sure both versions work. And I'm going to run it here. I can see you have the exact same cat, cow, dog, eel elements that you accessed before with the for each loop. At this point we could call it a day, but sometimes the question comes up, couldn't we simplify this code? Here I'm creating this private class only for one single area where I'm going to return an instance. And actually we can simplify it. We could also create an anonymous inner class right here inside my iterator method. The way I could do this is the following. I can say, well, we need an iterator string. So rather than creating this private class that has a specific name, I could just say, well, I need an anonymous inner class that happens to be an iterator string. And then we need a body that has the implementation of the iterator. So here is my implementation of the iterator that gives me the field and the two methods. I'm going to move those in my anonymous inner class. I no longer need my explicitly declared private class. And I actually don't need this type argument string here either because it can be implied. So Java can figure that out. Here we have a simplified version, exactly the same field, the same method implementations, but rather than having this private class that has a name, we used to call it word list iterator, I just specify here that we want to create a class that has a word list iterator, but we don't even give it a name. That's why it's called an anonymous in a class. Let's make sure this still works. I'm going to run it. And you can see we still have the exact same output. This was it. Have a good day.